So this is question number 26, everyone. In a region, the potential is represented by V xyz, 8x minus 6xyz minus 6yz plus 2xz, where V is in volt and xyz are in meters. The magnitude of electric force experienced by the charge of 1 microcoulomb situated at this particular location 101 will be what? Now we know that F equals QE. Magnitude of force on charge kept in external field is given by QE. So for force we need to require electric field. Now the electric field we can calculate from the given potential expression as EX, that is partial derivative of V with respect to x, dV del V by del X. That is, we have to differentiate this V with respect to X keeping other variables constant. So 8x gives you 8 minus 6yz constant, differentiation of x 1, minus 6yz, all are constant, so 0, plus 2 z constant, x has differentiation 1, so 2z. Now this value at 101 can be written as minus 10. So x component of field we have got minus 10 Newton per coulomb. Similarly, let's calculate the y component EY, that is minus of del V upon del Y. We have to differentiate the potential expression with respect to y keeping x and z constant. So this can be written 8x, all are constant, so that's why 0, minus 6xz, differentiation of y with respect to y 1, minus 6z, and this particular value at 101 can be written as 12 Newton per coulomb. When we solve it, we'll get this. Now similarly, let us calculate the component of z for electric field, minus del V by del Z, that is differentiating V with respect to Z keeping x and y constant gets us minus 6y plus 2x only, and this value at 101 will be minus of 2 Newton per coulomb. So these are the x, y and z component of electric field vector. So magnitude of electric field we simply can write under root of 10 square plus 12 square plus 2 square, that is under root 248 or 2 under root 62 Newton per coulomb. Now the force will be Q into E, that is 1 microcoulomb into 2 under root 62, or F can be written 2 under root 62 micronewton, because the unit of charge used here is microcoulomb. So that's why we can say that option number 2 is absolutely correct. So we can go with second option. Move on to the next, that is 27 number. Here is question number 27, everyone. A parallel plate capacitor is charged to a potential difference of 10 volts. After disconnecting the battery, the distance between the plates of capacitor is decreased by using non-conducting handles. The potential difference between the plates will be what? What will happen with potential difference? Now, this is the parallel plate capacitor. Capacitance at an instant given by C equals epsilon naught A divided by D, and if potential difference is V, capacitance is C, then charge stored Q will be given as CV. Now battery is removed, charge going to be constant. If the distance between the plate is decreased, means if we decrease the D, then what will happen with C? C will increase. Then what will happen with V? We know that V equals Q by C. If Q is constant, V inversely proportional to C. It means if C increase, then V decrease. So that's why we can surely go with third option, which is absolutely correct. option number 3. Move on to the next, that is 28 number. So here is question number 28 everyone. A conductor having cuboid shape has dimension ratio 1:2:5. The ratio of maximum to minimum resistance across two opposite faces will be what? Now let us think about maximum resistance. R maximum will be what or when? Proportional to L by A. If length is maximum and area is minimum, then resistance will be maximum. Similarly, in order to have minimum resistance, we have minimum length and maximum area. Now let us take the ratios. R max upon R mean will be L max upon A mean divided by L minimum upon A maximum, and after solving we will get L maximum into A maximum divided by L minimum into A minimum. Now these are the length, breadth and height actually, and the faces will be, means the cross-sectional area will be of rectangle shape. So we can write here the ratio maximum to minimum as maximum length with minimum length can be what? 5 is maximum, 1 is minimum. So 5 is to 1 will be the ratio of L max to L mean. Similarly, what will be the maximum area? Means 5 into 1 it is 5, 5 into 2 it is 10, 2 into 1 it is 2. So 10 is the maximum area of cross section, that is of rectangle shape, and 2 into 1, 2 is the minimum area. So we will get the ratio R max is to R mean, that is 25:1. Therefore we have to go with option number 2 only. Now move on to the next, that is 29 number. Question number 29 everyone. Two resistors of resistances 10 ohm and 40 ohm are connected with capacitor of capacitance 0.1 microfarad and an ideal battery of EMF 10 volt. Diagram is already given. When switch S is closed, then initial current and current in steady state through the battery respectively will be what? Now we know that at the instant when switch is closed, means at time t equal to 0, the capacitor will be short circuited and the circuit diagram looks like this is 40 ohm, this is 10 ohm and EMF is 10 volt. Short circuited, therefore this resistance will be what? Removed, and the current I will be V by R, that is 10 by 10, 1 ampere simply. But in steady state, we know that in steady state, in case of DC supply, capacitor is open circuited and circuit looks like here. The capacitor is open circuited, so we are having total resistance 10 and 40 in series, potential difference 10 volt only, so I in this case will be 10 by 50, that is 0.2 ampere. So current is what? 1 ampere and 0.2 ampere. We can say that option number 3 is absolutely correct, so we will go with third option. Now move on to the next, that is 30 number. So here is question number 30 everyone. The resistance in two arms of meter brace is 10 ohm and X respectively. The balance length is L1 from left. Now the resistance of 10 ohm is shunted with another resistor of resistance equal to unknown resistance X. Then new balance point is 0.75 L1. the value of resistance X will be what? Now this is the condition of Wheatstone bridge. So if here the L1 is balance length, so we can write 10 by L1 must be equal to X by 100 minus L1, and therefore we will get cross multiply 1000 minus 10 L1 equals X L1, and therefore 10 L1 plus X L1 equals 1000. Let us write it as equation number 1. Now according to new condition given in the question, if 10 ohm is shunted with another resistance equal to X, so shunted means parallel, then the new balance length is 0.75 L1. So resistance will be combination of 10 and X parallel, that is 10X upon 10 plus X divided by balance length 0.75 L1 equals X upon 100 minus 0.75 L1. X cancel out, and then cross multiplying we get 10 upon 10 plus X equals 0.75 L1 upon 100 minus 0.75 L1. So solving it, we will get 10 upon 10 plus X as 3L1 upon 400 minus 3L1. Cross multiplying, we will get another equation in terms of L1, that is 3L1X plus 60L1 equals 4000. Suppose this is equation number 2. Now taking the ratio of 1 and 2, what we will get? 10 plus X divided by 3X plus 60, because L1 will be cancelled out, is 1000 by 4000, that is 1 by 4. Cross multiplying gives 40 plus 4X equals 3X plus 16, and after solving we will get the value of X as 20 ohm. So therefore X is 20 ohm. We'll go with option number 3. Move on to the next, that is 31 number.